Hey everybody, this is Mr. Graybo. We're going to continue our work on this assignment called Boundary Explain, and then when you're done with that, I'm going to have you finish up learning targets 9 through 11. Now we haven't done learning target number 4, we'll complete that on Friday when I'm back. So let's get to it. Yesterday during class we should have filled out this first part here. We did divergent boundaries. And then for homework, I asked you to complete the paragraph that's a description of what happens at divergent boundaries. Okay, we'll continue on with this next part called Convergent Boundaries. I'm just going to go back to my slides here. Yesterday when we talked about divergent boundaries, we talked about the earthquakes and how the earthquakes would occur right at the boundary, right on the boundary. And also, the volcanoes are going to occur at this boundary as well, right in this area here, right in the middle of the plate boundaries. So just kind of a review there. One thing we didn't really get a chance to talk about is what if this happens on land? Well, divergent boundary can also happen in between two continents, and you can see what has happened right here when this happens in the middle of a continent. The continents will separate, and eventually they might even have water fill it in, and it can become a sea, like the example of the Red Sea here. So this just shows how that happens. You have two forces going in opposite directions. The land is going to push apart, and you end up with what's called a rift valley when it's on the land. Many times this will fill up with water, and you have lots of long, skinny lakes, or it could also become a sea if it connects to the ocean. Here's an example of the East African Rift Valley. Part of Africa is spreading apart. There's also an example in Iceland, where it's right in between two tectonic plates. So part of Iceland is actually pulling apart as well, and you can see these examples here. Okay, so let's move on. We're going to start to talk about convergent boundaries today, and then we're going to also get into transform boundaries. So a convergent boundary is when the plates are moving into each other. They're moving towards each other. Okay, there's a couple different examples depending on what type of crust is involved. You can have ocean-continent, continent-continent, or ocean-ocean. Okay, so let's start with talking about ocean continent. Now we know that the different types of crust, one is ocean and one is continent. The ocean floor is more dense, and the continents are less dense. Okay, so what happens is the seafloor, because it is more dense, is going to get pushed under or subducted underneath the continent. When a continental plate collides with that oceanic plate, since the ocean floor is super heavy, it's very dense, it's going to sink below the less dense ocean crust. So we get this motion of subduction here. Okay, this area in here would be called the subduction zone. Just where the one plate is sinking underneath the other plate and going into the mantle. Okay, what happens to this old crust is it's going to melt and it's going to get destroyed. It's kind of like the old crust is almost getting recycled back into the mantle. Okay, another feature that forms is what's called the deep ocean trench. When these two plates collide, it makes this V shape. It makes a very deep spot in the ocean. And if you've ever heard of the Marianas Trench, that's a really deep spot in the ocean. It's formed by this type of boundary. Okay, and now what happens? What happens here is as this melts, this magma will start to rise right here. you get a lot of carbon that gets pulled down into this area down here, and that creates a lot of gases, a buildup of gases like carbon dioxide, and that pressure builds up, and it makes its way up through the crust into an explosive volcano. This happens away from the boundary. Here's our boundary right here. But notice that this goes underneath the boundary. And so these volcanoes actually pop up off the boundary, away from the boundary. Okay, so our volcanoes, like I said, are off the boundary due to that magma that is getting melted down here, way away from the boundary. Okay, here's an example here. We have ocean crust being pushed underneath South America. When that happens, we see here's the boundary. We see this dark area that's called the deep ocean trench, and all these volcanoes popping up are off the boundary, way over here, not on the boundary, but away from the boundary. Notice we also have some earthquakes. Some are on the boundary, but some are way out here too, where that piece of crust is going underneath the continent. So this makes large and explosive volcanoes, like Mount St. Helens. Okay, the earthquakes, we're going to get some deep earthquakes, like in this area here. These are the real deep ones. This is where, like in the previous example, this piece of ocean floor is going underneath South America, and it creates that deep, deep earthquakes. It's also occurring over here near Japan. Okay, so the earthquakes can occur at all depths on and off the boundary. Okay, let's see. So here's our earthquakes. This is where they can occur. So they can occur up here, down here, anywhere where that plate is moving, you can have earthquakes. So they can be shallow, they can be medium, and they can also be deep. But notice here's the boundary. They can be on the boundary or way out here off the boundary as well. Okay, so real quick, we'll just take a peek at a couple other examples. So this is when two ocean plates collide. When two ocean plates collide, basically you have the same situation. You have one ocean plate colliding with another ocean plate. Whichever one is more dense or older is going to get subducted underneath the other one. So you have a similar situation where you have this subduction happening, only you just have two ocean plates. So what's going to occur is, instead of these volcanoes popping up on land, you get volcanoes popping up on the ocean floor. Eventually, the magma will build up so big that these mounds of lava, cooled lava, will make their way to the surface, and they become islands. Okay, so same thing, we have a subduction type of volcano. Okay, so here's just a good animation of what's happening there. One ocean plate goes underneath the other. You have melting, the gases build up, and it will explode off the boundary. You get volcanic islands. Okay, so again, crust is destroyed down here as it melts. Okay, we're going to create that deep ocean trench again, create islands, and the earthquakes, again, are going to be anywhere along this spot. So they can be shallow, they can be medium, or they can be deep. They can be on the boundary, or way out here off the boundary as well. Okay, so here's our earthquakes, and this produces very large explosive volcanoes. Okay, this is called the Ring of Fire. This is where this is occurring all over the Pacific. Good example is the Aleutian Islands. We have this ocean floor colliding with this ocean floor, and we have all these volcanoes. All these volcanic islands are formed from this plate going underneath this plate. Here's another example just out in the Pacific, the Marianas Islands. Okay, so now what's the deal with convergent boundaries when there's two continental plates colliding? Here what we get is we get two plates that are pushing together, but they're less dense. They're less dense than the ocean floor. So what we get instead of subduction happening is we get two plates that push together and they kind of push upwards. They're not heavy enough to get pushed into the mantle. They push together and they just kind of crumble on top of each other, called folded mountains. Okay, so this doesn't create any volcanoes, it just creates earthquakes and mountains. And these earthquakes are going to be fairly shallow and medium. Good example is the Himalayas. India is colliding with Asia. Creates this mountain range. They are not volcanic. Okay, so let's take a peek at our diagram. Okay, the motion at the boundaries, they're moving towards each other. We have an oceanic plate colliding with a continental plate. Earthquakes are going to be on the boundary and off the boundary. We're going to represent those with some X's. Here's where they can occur. Anywhere along that boundary and off the boundary. They're going to be shallow, medium, and deep. Volcanoes, yes. These volcanoes are going to occur off the boundary. And we call this slab pull. Okay, so as this magma down here melts, it's going to make its way up through the crust and make our volcanoes. Okay, this area here is called the subduction zone. And this is also where the old crust is destroyed. Okay, these are obviously our volcanoes. Okay, so your job will be to complete this description of what's going on. Then we're going to complete this next part about transform boundaries. So let's take a peek at that. So transform boundaries are real simple. Basically, they're just kind of grinding next to each other in opposite directions. Okay, our earthquakes are going to occur right here, kind of at the surface where they're grinding past each other. Whenever that slips, we get an earthquake. There's not going to be any volcanic activity here. It's just going to be earthquakes. Okay, here's some examples. You see how this railroad track is all crooked. That's due to these transform boundaries. Here's the San Andreas Fault. You see how this stream has got disconnected and it's actually moved. It's called an offset stream. Here's the San Andreas Fault that runs through California. So part of California is moving this direction, and part of California is moving that direction. Here is an animation of what's happening in California. So you can see part of California is moving a different direction. Okay, so let's finish up these notes here. So the motion is they're sliding past each other. Okay, here's our motion of the plates. They're moving in opposite directions. In this example, these are both continental plates, but this also happens in the ocean. Okay, earthquakes, there is no, well, I'm sorry. Earthquakes, yes, they are going to occur on the boundary, right where those plates are, and they're going to be shallow. Volcanoes, no. Okay. Let's see, features, we got earthquakes, and a fault is just this area right along the crack. It's a crack in the crust. It's just that boundary. It's kind of the same thing as the boundary. Okay, so go ahead and you can complete this part. Tomorrow during class, we will take a look at these maps, and we'll do learning target number 4. And that's it. Just submit the work when you're done, and then I want you to work on learning targets number 9 through 11. You should be able to answer those now. All right, I will see you guys tomorrow.